We want to welcome everyone here to the Flash the Station project. A lot of you know what this is. In case you don't know what it is, we're going to take those bright lights over there and this laser on this mount, and we're going to try to flash the International Space Station as it flies overhead. Luckily, Mr. Don Pettit, who's on board, will be able to see these lights, and some way or another will let us know that he saw us. Now, a lot of people have tried to do this, but none have been successful. So we think those lights down there are going to be our ace in the hole, if you will. Mr. Robert Reeves, who's standing off to my right here, he is friends with Don Pettit, astronaut Don Pettit, who's aboard the space station right now. They took off approximately 2 months ago from Baikonur in Russia, and we've been planning this probably for about 3 months. So there's been a lot of work here. A lot of people have gone out of their way to invest their time and in some cases money to make this thing happen. I want to thank Mr. Robert Lozano right over here of the Lozano Observatory for making this place available to us. Thank you so much.
Sure.
And our ace in the hole we would not have unless Mr. Ron, what's your last name, Ron?
Peters.
Ron Peters from Skyview Lights in San Antonio, gracious enough to not only bring one of the lights that we thought we were going to have, but a backup. So we talked him into using the second one. And then I'd like to thank Mr. George Cooper. George, where are you? George, right over here. He's still busy. He's the one that has put together the 1-watt blue laser there on the gun sight. So we're going to try and shoot that at the space station along with the 2 lights. Now, we need a couple of volunteers, okay? Oh, and here's Miss Joyce Lynch from the Austin Astronomical Society. I'd like to thank her. Y'all give her a hand for having a lot to do with this, please. And we're going to need, I think we have one person that's going to hold a board over one of the bright spotlights and flash it, as Mr. Robert Reeves here tells us, in cadence, on, off. We need one more volunteer that can do that with a board.
No.
Can we get somebody to help flash one of the boards? There we go. There's a hand. He can help us. He's a strong man. He can help us. Cool. What's your name? Stand up.
Jonathan Lozano.
Jonathan Lozano.
Recognize
Notice
Oh, yeah.
All right, now, because of the safety precautions needed for this laser, I need 2 plane spotters. I need 2 plane spotters, one on either side. Can I get a couple of volunteers that will watch for airplanes while we're spotting the station with the laser? A couple of people just to watch for airplanes. There's Ann Eames from SAA. Anybody else? One more? Can I get one more? Somebody just to watch for airplanes. That's all it is. Yeah. There we go, right over there. Cool. All right, now I'm going to turn. First, give all these folks a big hand, please. I'm going to turn the mic over to Robert Reeves, who is actually the person that has made this all happen with his friendship with Mr. Don Pettit.
Well, this project has been 9 years in the making. Don Pettit was also science officer aboard Expedition 6 back in 2002-2003, and slightly before he flew on that particular mission, he bought one of my astrophotography books and contacted me by email to chat a little bit about it. And one of the final things he said before he signed off is, "Oh, by the way, I'm one of the lucky ones. Someday soon, I'm going to get to fly on the space station." I got to thinking, spaceman, space station, he's an astrophotographer. Let's see what he can do up there taking pictures of stars from the space station. Well, he decided that was a pretty nifty idea, and he tried it, and he found out he could do no better up there than he could down here on Earth. So he took his astrophotography rig, turned it upside down, and aimed it at the Earth, and ended up shooting 4,000 pictures of cities at night. And it turned into an excellent database for light pollution studies, urban sprawl studies, and so forth. And Don and I continued on with other various little photo projects up through STS-126, which flew 3 years ago. And that was kind of a test bed for a lot of the stuff he's doing up there now. He's pioneered the use of Nikon D3S, which is a full-frame Nikon digital camera, DSLR. and he's using it to create movies of aurora from orbit. And I urge you to go to spaceweather.com. That's spaceweather, one word, .com. It's the internet source for sunspot and aurora information. And currently playing up at the top of the page is a prominent link to a movie of his aurora images taken from, or his aurora films taken from orbit with this Nikon camera. And the title of the movie is Aurora Underfoot, because he's actually looking down at the aurora or flying through them instead of looking up at them like we do. And another thing Don does with his cameras, he tries to photograph meteors in the atmosphere. Instead of looking up like we do, he looks down. He's found a particularly interesting class of meteors while he was on Expedition 6, where the meteors were apparently at his altitude or higher. Now think about that a minute. There he is flying along 200 miles above Earth, and he looks out the window and there's a meteor going by at his altitude that's on fire. Why isn't he? So that's a little puzzle we're working on. So he's got his finger in a lot of little interesting observing projects that aren't necessarily NASA science sponsored projects, but as a scientist, he likes to play with what he calls science of opportunity. And things like watching iridium flashes from orbit, which is a real tough call because not only is the iridium flare moving across the surface of the Earth in a finite spot, the station is moving too, and they've got to intercept each other. But we've found a way to help him see these things. This project tonight, this is another experiment in the science of opportunity. Nobody's ever successfully done this, but when we proposed it to him and told him how we were going to do it, it got his interest. He said, yeah, we've got a pretty good chance of pulling this off. Now sitting over there doesn't look like a whole bunch because you're not staring down its throat, but that is 1.6 billion lumens shining into the sky. We estimate that at Don's altitude, at closest approach, if we successfully point these lights at him, he should be able to see us as a -5 star, brighter than Venus. But there's a hitch. The space station is in sunlight. We're in the dark. We have to be in the dark in order to see the space station. So the problem is, Don is viewing us from what is called the cupola on the space station. It's a kind of a bay window in the belly of the space station that looks down at the Earth. It allows the astronauts to see a panoramic view of all the way around the horizon. Instead of looking out through a flat window where you can't look forward or back, they're able to kind of stick their head out this bubble and see all around. But that puts him square in the middle of a little ball of sunlight shining into the cupola. So our worry is that sunlight will dazzle him and he won't be able to see us. That's the only fly in the ointment. I think we've got the firepower to punch through to get up there if he can be dark enough to see us. So this whole thing is going to be an experiment, and if it succeeds, we will be the first in the world to ever do this, to succeed at it.
Very cool.
We've got somebody upstairs who is interested enough in what we're doing to give it a shot. So quite a few things have come together here. Like I said, 9 years in the making. When he was up on Expedition 6, I wanted to do something similar to this at the Texas Star Party, but we had no available passes where we could coordinate. So this is our first shot at it. It may be our last shot. So we're going to give it hell. So I think we need to start getting in position here, because when the station comes, it's not going to wait for us.
Yep, got 14 minutes.
14 minutes? Okay.
Yeah, we're about 14 minutes away. Don will be orchestrating the flash, okay? Robert will be orchestrating the flash, I'm sorry. And that means we're going to cover the lights, uncover the lights, cover the lights, uncover the lights at his direction. So that's what we're going to do. So we want to get all the volunteers in place in about another 5 minutes, and let's do just a real quick rehearsal of what we want to do. All right. Thank you for everybody for coming. I hope you have a good time. I hope you get to see us on the news somewhere, or some kind of published thing that a bunch of crazy people got together in the hill country and pulled off an unbelievable feat. Thank you very much for coming.